Next, we have the panel, and we'll continue with the IoT and security. So apart from the three speakers who talked about it, we have Vinayak Hegde, who is the CTO of Zoomcar. He will also be talking in the deployments track about the work that he's doing in his company. And then we have Rahul Jadhav, who is an architect at Huawei. And then, of course, we have Lee here, who will be moderating. And he's the IPv6 guru here. So let's get.
So you can expect an IPv6 question at some point.
I think I suggest you use this.
I'll use that. Oh, have the panels. Perfect. Good. IPv6 costs a lot less than $200. So yeah, thank you very much. I promised myself that I would never actually sit on a manel before. I don't know if you've ever heard that term. It's a panel of all men, and I know that this is not representative of engineering in India. So I challenge you to work on that for the next association. So I also want to point out that I always like a panel where there are lots of questions from the audience. I have a couple prepared, but I want to hear what you guys have to say, what you have to ask them. But while you're standing up and coming to the microphone, why don't each of you spend just a couple of minutes? Actually, I'm going to start with at that end, because some of you we've heard from already today, and some we haven't. So who are you? What are you working on? And what are you excited about in the IoT and maybe the IoT and security space?
So I'm Rahul Jadhav. I'm a lead architect at Huawei Technologies India Private Limited, and I am part of a technology development team which works on smart grid networks, IoT networks. We primarily use 802.15.4 mesh networks, and doing security on top of it is particularly challenging. And this is some of the context that I come from.
Hi, my name is Vinayak Hegde. I am the Chief Technology Officer at Zoomcar. We are India's largest car rental company, and now we are slowly becoming a mobility company. We also launch cycles which are IoT enabled. Hopefully we'll be doing a demo today, a demo tomorrow at the deployment track. What we do differently, I'll just focus a little bit on that, is most of the things that people talked about here, those devices are static. But we have additional challenges because cycles and vehicles are moving, and we still get data from these connected vehicles. And that leads to several different challenges because multiple people have access to those vehicles. Also, they may not always have connectivity. I mean, which might be common in static devices as well. But if they are moving, then there are additional challenges with network connectivity as well. So I'll be talking more about that tomorrow. But that is like my background.
Do I need to still introduce myself again? Who doesn't know me?
Say something new about something you're excited about in the space.
I'm excited about IoT security. I think there is still many problems that need to be solved. There is a bunch of people working on it. I don't know. In general, I think security authorization for IoT devices is still not a done deal yet. So more work to do for all of us. We'll keep getting our salaries for a while.
What he said.
I'm excited by running code. About 3 weeks ago, I learned that a large company has implemented a whole bunch of the Brucey specifications, and somewhat annoying to me is they haven't said anything about the specifications themselves, which, they've gone and implemented a huge amount of stuff, and that's so exciting. And they've been completely quiet about it, and I don't know why. But I'm still excited about that.
This is a great chance to come to a microphone and ask a question. Anything in this realm of space, please. I've got another little editorial while you're coming to the microphone. For an IETF meeting, we would all be way overdressed.
Hey. Hi, I'm Kailash here from Ericsson. So I would say it's paradoxical, or would it not? At one end of the point, you have security. We need to make sure that devices are secure. Nobody can hack through it. DDoS. Other end, there's a cost. We want this cost of the device to be as low as 100 rupees, one of our panelists pointed out. And it should be easy to deploy and bootstrap as well. Right? So it's not only the security that we are talking about. It's, I would say, the triangle. Maybe there are other aspects to it. How do you approach toward this? Thank you.
Maybe I can talk from some specific deployment issues that we faced. We started off with devices which had like 64 KB of RAM, and we tried to tackle the problems towards network access. We tried to basically our performance criteria was like having best network convergence time on a mesh network which contained like 1,000 nodes working on top of 8.2.15.4 severely constrained networks. But then when we brought in security aspects, like eventually you have to, so the whole game changed, and we had to go back to the product lines and tell them that, it's impossible to achieve with this kind of memory, it's impossible to achieve with this kind of MCU, the security that you are expecting to have, and you have to change. You have to change. At some point of time, you have to ask for a better specification, better node specification. There is an additional cost involved. But yeah, that additional cost has to be borne if you want to have a security, like you mentioned. In case of Noob, there is some additional user interface that you have to bring in. That is the cost that has to be brought in. It not only has an implications on the cost, but the overall performance. You expect a network convergence time to happen in like X minutes. With security, it goes to 2X, easily. And then the whole strategy, the deployment strategy, the competitor strategy, everything changes there. We found this problem. So we initially started off working with a device which had 64 KB RAM. Eventually we switched to STM32F405, which had 192 KB RAM, because we had to support so many number of hops, which we have to support so many number of nodes in the network. And yeah, that is a call that eventually product line has to take. Yeah.
We have cars and cycles, right, which are live right now. And Mohit talked about static codes. I'll give you a very live example where security is really important. So we were one of the first to launch the cycles business, and the locks were connected to the internet. When the computers came into the market, they were like 4 or 5, and now that has kind of whittled down to maybe 2 or like 2.5, because one is dying. So we deployed it in, I won't name the competitor, but the competitor actually deployed with static codes. The way our device works is that you scan a QR code, and then it connects to the server, and the server authenticates and connects with the device, and then it authenticates. So there's nothing static, and we don't trust the user's phone as well, so we don't generate the code there as well. The computer said, okay, security is not important, I should be first to market. What happened was they had static codes. So now this was, deployment was in IIT Madras. So these IIT people are pretty smart. So they figured out, oh, this is static code. So once they figured out that this is static code, they basically took the cycle, pre-painted it, and then within like 1 week, they had no business. That's one. And I think one of the comments that I made, one of the questions that also needs to be answered, and which is out there, is suppose like the Mirai attack happened, who should bear the cost? So we have this tragedy of the commons. So many and more devices are getting connected to the internet, and that can be used as an amplification attack many times, and unwittingly many people become witnesses. So as engineers, if we don't solve this problem, the whole environment, which is the internet, can be kind of completely destabilized. So this is a problem that we need to solve. So the security is not only as a cost, is not only cost for the manufacturer or the user, but it's also for the ecosystem.
Maybe I would not say a very long comment, but advise you to read RFC 8387. Yes, I am a co-author on that RFC. But basically the recommendation of that RFC, that the thought process should be, this is what I want to do, and then I pick the platform. Not, this is the platform I chose, and now I somehow need to fit security, somehow need to fit network management and things like that. That's bad way of approaching a solution. Instead, first say, these are my requirements, these are the security I want, and then go and pick a platform. Because I see so many times, my device cannot generate random numbers, so I'm going to use the same number for sequence numbers. I'm going to use the same number for generating keys. well, good luck then. I can't help you. If you're not willing to pay the price for having random number generators on your device, and you need them for many things, not just for keys. You need them for nonces, for sequence numbers, for so many things. And if you say, well, I have a budget of only 50 rupees and I can't afford a random number generator on this platform, well, then don't expect security and please don't connect it to the internet.
So the only thing I just want to reemphasize out of all of that is that it's incumbent on us as the people who are the, in the IT field to help the people in the OT field do the right thing. If we make it too expensive for them to do the right thing, you can bet that economics will take over and they'll simply do the wrong thing. So to me, the way we do that is to find the architectural commonalities to allow for multiple deployment scenarios to be accommodated, such that the cost of goods and services to deliver those capabilities is minimized. So what does that mean in English? What it means is, if we look at the differences between the work of Michael and the work of Mohit, for instance, and we say, well, where's the commonality? You already heard, I think, sort of one grain of commonality, which is sitting between the two of them, which is, let's figure out how to do some of this through EAP, right? Another grain of commonality is that you need to have an assertion transmitted back into the device. How that assertion happens is different. Okay, that's a problem we have to solve for on the IT side. We can't afford to have, there's not enough commonality in that assertion. I don't know enough about Noob, to be honest, to figure out whether really we should be going with a new format of assertion. But I know we have a way to do it in 8366, the voucher format. Is it right for Noob? I don't know. There was a commercial on in the United States for years called Reese's Peanut Butter Cups. You may have had one, in which one person said, hey, you got your chocolate in my peanut butter, and the other person said, no, you've got your peanut butter in my chocolate. So I think we have to figure that out a little bit. And unfortunately, it's not just Noob and this and that. There's a dozen of these things.
But the peanut butter and chocolate is all delicious. That's right. I wanted to say two things. One thing is, a couple of years ago at DEF CON, Dan Geer did a keynote which was called Cybersecurity as Realpolitik. And I'd really urge you to go look it up, Google it. It's a YouTube video and someone transcribed it. It's kind of a better read in some ways. But he talks a lot about it in terms of liability for devices and who's liable. And we do not have, I say we, I mean Canada, the United States, I can speak of authoritatively, and I don't know where other countries go. We do not have really good liability laws in terms of the responsibility. The fact that D-Link was finally penalized for having bad security on their routers, their home routers, was revolutionary. But it needs to be repeated probably several dozen times over. As to Mohit's point about Cyanogen, and I really have tried to run it on every phone that I've ever had, and I build it from source, and I do all sorts of things like this, and I'm dismayed by how hard it is. And part of the reason is because the manufacturers are trying to take responsibility for my phone's security, and part of that process is to keep me from replacing the code. And so there's a real problem here, because I want to replace the code because I don't trust them, and they don't want me to replace the code because they don't trust me. And yet we both want my phone to be secure, right? So the other part that I wanted to say is that one of the first pieces of work that I did in the role working group, which Rahul has participated a great deal in, was to deal with the threats analysis on the role protocol. And we had a whole long list of things, ways of attacking routing protocols. They were all very interesting. Some of them were very sophisticated, and some things were a little bit weird. Like, for instance, can I prevent you from putting a expensive coax cable with an antenna on this side of the room, and running it to the other side of the room with another side of the thing, completely passive. This is no electronics involved, right? Maybe a bit of an amplifier, like a couple transistors, kind of an op-amp there. Can I prevent you from doing that? Because that looks a lot like a routing attack, where you make it look like the two sides of the room are closer than they are. And it doesn't involve breaking any encryption, because you've never attacked the thing, right? And so one of the questions was, well, this seems unpreventable, also undetectable. And we sat down and said, does it have any real effect on things in the end? Well, it's much more efficient to suddenly, route from this node over here to the one on the way in this other side of the room, and they look like they're much closer than they are. And that's a real issue. Well, in the end, what we said is, look, if you did the security right, in other words, if you paid for the security parts of the protocol and you didn't just do something dumb, it didn't matter. That attack was a moot point. The bad guy just did you a favor, okay? Made your network more efficient. The attack is when he disconnects the cable and your network breaks because you didn't know it was efficient, right? And maybe that's the problem. But one of the things that happened in that process is we realized that if you applied the security well, a whole ream of other attacks on the protocol became infeasible or irrelevant, okay? And I think that's the key thing about what's happening now with HTTPS everywhere, for instance, is that is making a great deal of worries about attacks on TCP sequence numbers and other things like that kind of irrelevant, right? Like, you know what? TLS was expensive 20 years ago. You wouldn't do it anywhere. Today, it's really cheap, even in the data center space, especially in the data center space, I would even say. So suddenly you just put it everywhere where you need it or not. And I think that slowly we're getting there in IoT, where people are realizing, you know what? I'm going to buy a device a little bit bigger than I needed to anyway, because next year it'll be cheaper. The one I would have bought will be will be end of line anyway, and I'm going to use that RAM for something, I don't know what, but I'll use it for something.
Lily.
Delaney Elkins. One of the things that you said, Michael, made me think about something that I've been thinking about a fair amount recently is, and something Vinayak said too, is about legislation. I mean, do we come to a point, or when do we come to a point where somebody decides they have to step in? And it seems to be happening more and more, as you see it, especially in the EU, which has become very, very aggressive. Australia, too, is very aggressive. So I wanted to pose a question to the panel for each of you. What do you think is the worst thing that you could imagine happening in an insecure environment for some IoT devices that you're working with, or that you know of?
You're asking for a worst case technical scenario or a worst case legislative scenario?
No. Worst case technicals. What's the worst that could happen that you can think of? Legislation, they're going to do something terrible. I mean, that's just a given. Let's just not go there. But what do you? I mean, it's like just to throw something out, like from Rahul. I mean, you take out the U.S. power grid to New York City, to Manhattan. Yeah, okay. I mean, but maybe it's protected. But I mean, you guys, it's your world. It's not my world. I mean, what? You tell me what could happen.
You can start.
It's Halloween, so scare us.
It's Halloween.
We could do like a lightning round on this, right? 3 seconds and come up with one bad case and just pass the microphone, okay?
And then keep going around.
So here's one that I like: nuclear power plant failure. Go.
The smart meter grid been hacked by 8 years old, and the news popping up on the register.
Some of it is actually already happening. Nuclear power reactor Stuxnets, for example, that has already happened. That's one attack. Using IoT devices for war, that also to some extent is happening, especially the CIS states, which are the former Soviet Russian blocs. Russia has tried to attack the network infrastructure of Estonia, of Ukraine. So you can disrupt all communication, and whether it is TV, whether it's radio, a lot of it actually now goes over the internet. So you can completely break down communications of the country, and there can be total chaos while you actually have military attacks happening. These are all possible scenarios. Some of them have already happened.
People are going to die. But maybe my more serious worry is with all these security attacks, and you probably already see a lot of evangelists who say we shouldn't be connecting devices. These devices should be offline, and maybe many of them should be. I don't see any reason why I would want to connect my toaster to the internet, but I'm afraid that if we keep going down this path of disconnecting and disconnecting and disconnecting, we are losing the benefits of connecting devices. Yes, security is a big challenge and we need to solve it, but I'm also afraid that because security, we might actually see more and more people who are now going around and saying we don't need to connect devices, let's all stay offline and disconnected, or let's have these small breakouts of internets and not connect anything globally.
There was a movie, it was called Enemy of the State with Will something, Smith, I think it is. And I think they did a very good job of explaining what could be done to you personally with a good IoT, insecure IoT attack on you personally.
I'll just add one more example. There's a dryer that is IoT connected now, a clothes dryer, and the PLCs, the programmable logic controllers for the tumbler and the heater are separate, and firmware updates go in the clear. So that means an attacker could stop the tumbler and turn on the heater and cook every last dryer and the houses that they're in at the same time. I'm not going to name and shame.
Hi, Rohit from Huawei. I wanted to post a question in the medical angle, basically. So there is, many people consider that having your phone nearby for long duration, you are exposed to radiation. So now we have a lot of devices. We are talking about having smart devices in our home. So going through in the buses are also smart devices. Then in office space there is smart device. So is there a threat of having prolonged radiation? And is there someone who is there any entity that is controlling or measuring how much this solution, this IoT solution, is going to cost you with respect to health? And yeah, that's it. Thank you.
It's not a strictly a IoT and security question, but yeah, there is regulation regarding how much power transmission should be there for base stations, for mobile towers. I think FCC in the US regulates that, and I think similarly there are other regulators elsewhere also that regulate that. But whether you like it or not, I think we are going that way. So I don't see much that we can do. I mean, individually you can do some stuff, but as a community I find it very hard that we are moving away from that. The horse has left the stable there.
I'm not a fan of Wi-Fi. I think it sucks. I think it's poor. The performance is always poor, and no matter what, all these AC and all these other letters we get on it. You add a 5 or 6 machines in your house, and it goes to crap. My Wii's attached to gigabit Ethernet because I like my Netflix to stream well, and I really am upset that Chromebooks don't come with Ethernet cables, and I'd really like all of the Chromebooks in my son's school to be wired. And that's not because I'm worried about the Wi-Fi radiation. It's because the experience in Wi-Fi mostly sucks in big places. It's hard to engineer that well. 802.15.4 is significantly lower powered because it runs batteries, and because of the mesh network of it, it's much slower. It's not going to do gigabit, right? Okay. but it's perfectly good for a great deal of IoT things, and the power rates are much significantly lower. So I think that's important just on the basis of energy savings to do that. There's a lot of contradictory reports about Wi-Fi and all this kind of stuff, and I'm skeptical about most of them personally. I'm not particularly anxious about the radiation. I've heard things that 5G is going to be worse from people that I don't really trust to, do math properly, but let alone be scientists. But at the same time, there is a fear, and I think it is reasonable from a sociological point of view to acknowledge the fear that's there. And I think we need to understand what's driving it. And I think we have to do some real research into, is there something else going on? Because I think that there probably is something else going on. And it just may not be related to 2.4 gigahertz in your head.
I was just going to add one comment, which is from a risk management standpoint, I'm not sure this is the top of the top of my thinking. I'm worried more about crossing the street, actually, as being more risky than that. Perhaps what I'm eating as being more risky, and the fact that I have friends who smoke, and they smoke in front of me, and that's a problem.
Yeah, I'll just make a quick point, and probably Elliot also said it, that is radiation bad for us? Yes. Is sugar bad for us? Yes. But, the government sets some regulations, and then we live by them. If government allows Coke and Pepsi to sell their soft drinks, or all these energy drinks, we trust that the government has done studies, and there is use in reasonable amounts is okay. The same for radiation. So FCC in the US, the same for Indian government, sets some radiation standards, and then Huawei, Ericsson, Cisco, all of us meet whatever standards are set. Yes, you could argue that maybe these companies are actually bribing the politicians to set standards which are beneficial for them, but you could argue the same for Coke and Pepsi. So yeah, it's a question at least beyond what I am working on, but I trust the regulators are doing a fair enough job, and many of us are going to get cancer anyways. So,
so I can quote an example here. So there had been with regards to smart meters deployment, there had been huge protests worldwide, and about this concern of radiation, and there had been studies done by NHS. Now I have not personally read that because that is beyond my comprehension, but there had been a public issual of what matters. They clearly have mentioned what is happening, and what is government doing, and what are the regulatory authorities doing, and what are the companies should do. So basically, most of the times, a big scale network, there is some sort of regulatory mandate posed on them. For example, for smart meter networks or for smart city networks, there will be some sort of. So the best that we could do is comply to those standards, and make sure that those standards are met and followed. That's all.
We have about 6 minutes left, and 2 people in line. So if you would like to ask a question, please stand in line, because we're about to close the mic lines. And then I'm going to ask the panelists to respond quickly to the next few questions.
Hi, my name is Vineet, and I just had a question about, IoT, it appears to be either tied to the merchant, or it's not tied to the merchant, and we want it to be open source and all. So if the IoT device itself, if it is vendor neutral and kind of commodity hardware, then wouldn't that is that where we are heading, where it's kind of a vendor neutral commodity hardware, which we just any merchant can
I
work
think
on
I get your point. So at the base level, there's maybe 6, maybe 10 manufacturers of processors that are regularly and commonly used in IoT devices. Unfortunately, as they're constructed and put together, so there's a fair bit of commonality that way. And there's a good possibility you take an average IoT device and you do a certain amount of reverse engineering to get into it, that you're going to be able to write code for that device and make it happen. you're probably going to have to break into it. And the reason is because in many cases, and the hardware manufacturers are very specifically doing things like this, they really want to make sure that there's no malicious code that gets into the device. And that is a noble and goal, and I'm really support it. At the same time, I really want to have open platforms in which we can do things. And those two things are presently they're fighting, okay? And so that's a real issue, and I'm very concerned, and I would really like devices to be recyclable in the sense that you could take a device from a manufacturer that's gone out of business, who doesn't want to support it or whatever, and you could recycle it into some other use, okay, in some other way. And in many cases, it's, you just need a new case and maybe you change the sensor or the battery. And I think that's really important. It could happen. I think we're going to see in the same way that, we saw, trying to think of a good example here. Well, I mean, it hasn't happened in the home router manufacturers, but it kind of has. We have a great deal of them that are running OpenWRT, but you can't flash your own version of it onto the router. Okay, so we're slowly getting to the point where people are realizing they want some openness, and I think that's going to happen. It just hasn't happened because we don't have a competitive market in, air quality sensors or something like this. It's not open. They're verticals. Right now, it's vertical, 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 and the process of standardization is really to chop part of that vertical in pieces. And we can get some commodification at the low end, at the bottom of the device end. And I think that'll be really valuable. I think it'll do what you want. We'll have now devices that can be open and you can change what they do easily and things like that.
Yeah, and that will probably reduce the cost as well. Many people were complaining.
Well, actually, as to your point of cost, one of the things that you see is that you put as little into the device as you possibly can, and you shift the computing power into a shared computing resources in the cloud, which is why you have this whole cloud-based architecture that you see with IoT. Well, that means that the device actually needs to talk to someone, and it needs to talk to the function that actually has the real capability in it. So if I've shifted all my analysis into the cloud, the device has no analysis capabilities. You have to have a compatible analysis capability in the cloud. So the onboarding aspects of this are only a small portion of the vendor dependencies that are developing between the device and what functionality exists outside the device.
Moving on, because we've got 3 more people in line and 2 more minutes.
Abhijan Bhattacharya, TCS Research. I'm standing on the mic for 2 things. First one is a comment that is on the health issue. When we essentially talk about the health issue, we probably think about the human health. So a question like, if I have a Bluetooth headset over here, does it cause brain tumor or something like that? But I think the matter has to be looked in a broader spectrum, considering the ecosystem in which Mother Nature puts us. For example, I come from Bengal, the Gangetic Bengal, the largest delta in the world. We had little sparrows that used to throng our houses, okay? Every now and then in our study room, they used to sit on our study tables, so we used to play with them. These days, we don't see them. One article by some local research agencies I read, and they were claiming that probably the spread of mobile towers is causing something to these birds to sustain. I don't know what is the validity, that is not yet supported, but one thing, when I'm putting the radiation there, so how is it affecting the tiniest creatures? That is also something probably that should be in the radar of analysis. That is one thing, because that has a larger impact. Anyway, we are killing it, still we are surviving. We are killing our ecosystem, still surviving, but it is not bad to think about. And the other thing is that while we talk about IoT security, I just want to understand whether application of quantum computing is becoming a reality day by day. And public key crypto is now vulnerable thanks to Shor's algorithm, which says that the order of n complexity or the polynomially hard problem of getting the polynomials out, the prime numbers out, is now can be done by n by root 2 or something. The complexity has drastically reduced. Whether it is a high time that IETF and all these discussions, they should consider quantum crypto and quantum safety as something in their radar. Thank you.
I think we can take all the questions and then answer them together because we are very low on time. So we will answer, but let's take all the questions.
Hi, I'm Kristen from RV College of Engineering. So I have a very technical question related to IoT security. So in my private home network, I have a lot of sensors, and I'm using MQTT to talk to them. So in the home network itself, I have MQTT publisher as well as a broker. And in a remote network somewhere else in the world, I have a publisher, right? So how do I make this MQTT broker? How do I open a port in my private network so that it's not hackable by, as we said, Mirai or whatever it is? So what's the safest way to go about this? And I'm also thinking, is EAP-Noob one of the ways to go about this? So yeah, that's the question.
Thiru, McAfee. I mean, the work happening in IoT security is the right way to basically address various threats, right? But one of the challenges that we've been facing is the home users, though they have, like say we ship secure home platform like a gateway, like a firewall to protect the IoT devices, they just don't care about, let's say my IoT devices get compromised and they're attacking some target in the public internet, right? I mean, though we identify and tell the user that, hey, I know your device is infected, it's attacking certain targets, they just don't care about remediation, unlike enterprise networks, right? Pretty much the typical IoT device infections that are there we're seeing today is basically DDoS or crypto mining, basically, and they're not targeting the home network, but botnets could basically later in future phases could target the home network. So how do you envision we educate the home users to basically take the right measures to basically remediate or upgrade their firmware or basically talk to the manufacturers and get the right firmware versions? Because those IoT devices are really vulnerable. I mean, we're just talking about authentication and bootstrapping, but beyond that, we've seen various types of infections that get infected and the home user doesn't really care. And then how do we protect the home user network itself and then protect the public infrastructure, right? So there's two different attack vectors that are really compelling, and how do you envision that we protect the both these attack vectors?
I did close the mic, but go ahead, make it quickly.
Hi, I'm Sailaja from IP Infusion, and sorry for being late in the queue. My question is related to EAP-Noob. The QR code is dynamically generated, depends on the network where the device is placed on. So if I change the place of the device to connect to the different list of networks, the QR code may change. Then how it is authenticated that it is really secure?
So maybe now we can answer, and since this was a specific question for EAP-Noob, maybe I can begin by answering this first. So the idea is that if you bootstrap the device here, it sees a certain set of Wi-Fi networks, it shows you a QR code, and you scan the QR code, it gets associated with your account on the cloud. Now if I take this device, bring it to my home, it sees a different set of access wireless networks, generates a different QR code, and I scan it, it goes to my cloud account and gets associated with my account. So whoever is the user who is completing this process gets control of the device. So that's the security. And then we had three questions. One was quantum computing, one was can I use EAP-Noob for MQTT brokers on the other side of the internet? What was the third one? About this firewalls and how do we encourage users to care about security. Maybe you can do closing remarks on answer the three questions one by one.
So I'll answer maybe Thiru's question. So I think the answer is like, I mean, if you've seen the evolution of security or the awareness of security even within the IETF, earlier people were pushing security, but I think the biggest impetus was given by the Snowden revelations, right? Similar kind of thought process is actually happening because of Stuxnet, Mirai botnet attacks and various attacks that we have seen in the wild. So I think we need to move to a mode where it is like secure by default, where there's as less configuration or as less interaction needed with the user within certain limits. But yeah, secure by default needs to be there, and that is, I think, the conversation that needs to kind of develop. And if you see, all of these approaches have come from that kind of background. People are realizing that not having secure by default has cost us a lot. A great example where when the internet actually came about is email. Everybody trusted each other, and today we have the problem of spam. We've tried to fix in retrospect, but it was not one secure by default, and security was not inbuilt from the ground up in the protocol, and we are still paying the price of that.
So one of the questions that one of the points that I wanted to mention, which surprisingly was not covered by any of the talks today, was regarding the cybersecurity issues of the implementation. So in most of the cases, most of the constrained devices are implementing some sort of non-hardened operating systems, network stacks, and those are not as secure as Linux or Mac OS or Windows, which have been in market for so long. So yeah, and this is one of the key concerns that me as a technology development team has, me and my team has. So if you see most of the operating systems and the network stacks that are in use, those are pretty much very vulnerable. It's impossible to use Linux on those kind of systems. So yeah, the second point about the quantum computing, we are not really. The way we have approached it is that most of the security standards that we follow or guidelines that we follow are derived from the NIST standards. So yeah, if quantum computing at some point of time is going to break this security, then there would be an advisory issue, and we will have to be catering to the new standards. So, but yeah, that is how. Yeah, it's a reactive approach, but yeah. Yeah, we are supposed to put it there.
So to answer Thiru's question, you can have black lists and white lists. So instead allowing everything to go by default, you block everything and then ask the user, should this device go? Or you could use something like manufacturer usage description, where the device itself tells that these are the only servers I should talk to, and anything else should be blocked. I mean, there are some deployment challenges. You have to require the manufacturers to use this file and format and then send, but there are technical means of doing that. So that's maybe answer to your question, to Thiru's question.
So one comment I wanted to make, because we're talking about the ITF, one group I think people can follow is SUIT with respect to updates. SUIT, secure updates, is a group actually looks at how to do over-the-air updates when multiple manufacturers are actually trying to upgrade firmware. So there is actually work happening in that respect. So just wanted to add that.
So one of the things that SUIT's pushing very hard for is, yes, of course, we'll have asymmetric ECDSA or RSA keys, but one of the things we push very hard is that we need the first iteration of the spec shall also have hash-based signatures which are quantum resistant, because once we figure out how to actually have something efficient that's also quantum resistant, we'll have to upgrade everyone's firmware, and we better not have a quantum attack while you're upgrading your firmware to be quantum resistant.
And I'll just end on that point too about quantum cryptography. I want to generalize the point, which is that any cryptography that goes into the device today will break. And one of the issues we have with IoT devices is that their lifetimes generally are all over the map. They can be as short as 6 weeks or as long as 40 years. There's no crypto technology out there that has withstood 40 years at this point, with a possible exception of RSA.
Okay, I think we are out of time. I'll close the discussion if that's okay with the rest of the panelists. To answer a question on quantum computing, we knew SHA-1 is broken in 95. It still took us 20 years to actually find a collision attack. So it takes a lot of time. I would stick my neck out and say we are still at least 10 to 15 years away from seeing actual quantum attacks. And as Rahul said, we wait for NIST guidelines. So NIST is currently running a competition on prospective quantum resistant solutions. Once we see some results from that, we'll probably see some deployments. You could already take steps now by making sure your protocols don't limit the size of the message by not using TLVs and instead use something like JSON, but maybe that's important. Finally, I would say that penicillin cannot cure bacterial infections, but at least we have TLS. So instead of focusing on some new crypto algorithms and this and that, I think we should use something that is so well engineered, has tons of people reviewing it, and try to use it as much as possible. Of course, TLS doesn't solve the problem of bootstrapping, doesn't solve the problem of authorization, and that is where we need to be working on, rather than defining perhaps new communication security protocols.
Wow, that was fantastic. I appreciate the fact that I didn't get to ask any of the questions that I had come ready to ask. So that's fantastic. I'm going to be talking to some of these people over lunch. I hope that you will approach them too and ask whatever other questions that come up for you. I want to thank the panelists and thank you all for asking so many questions.
Thank you.